Hi everyone, today we're going to do some IPSEC and VPNs using Cisco routers, of course, in our GNS3. As you can see, I've already configured all the topologies in our network. Just gonna open this. Yep, opening everything. Yeah, turns out what R1. So. Also, we have applied some Wireshark, so we can actually see the differences later. So we have a point of reference. So you see, yep. Okay, start. Yeah, password is pass. So I'm going to show you show IP interface brief and show IP protocol. Yes, I've used EIGRP for our routing protocol and show IP route. I'll show you that we are all connected. To enter a class here, show IP interface brief. You can pause the video if you want. Show IP route. Same. Pass and show IP interface brief. Show IP routes. Yep, they're all already configured, our network topology. Now then, I'm going to show you our Wireshark. Turn it on first. This is our Wireshark, so we can see. You can see that I am using EIGRP protocol. Look back, I haven't actually configured the look back interface. It's fine. This is a CDP for switches, trying to find neighbors and such. Hello. Now I'm going to ping PC1. Going to PC1. I'm going to ping PC2 from PC1, and let's see what our Wireshark can capture. So I'm pinging it right about now. Ping 20.20.20.2. This is our PC2. Apply display. There we go, we have a PC. How the mark unbound? Oh, there we go. Colors, light colors. So as you see, we have successfully pinged ICMP, and unlike our data here, what are our frames? And our frame is Ethernet type, IP, ICMP, and data. As you can remember, we have used GRE. We actually encapsulated it in the header in GRE. So you can see it here. That's a reference point. Nothing wrong. So let's start configuring our ISCAM policy. I'm going to remove WS first, and let's configure first our router 1. So for every VPN using IPSEC, of course we're going to use IKE phase 1 first. So we're going to configure IKE phase 1 first. Before doing that, I'm going to show the policy. That's ICE. Show crypto map ISCAM. Show crypto ISCAM policy. As you can see, we have our default policy enabled. You don't have to actually configure this, it's already enabled. So policy, yep, it's also already enabled. So there's that. Also in GRE, our terminal mode is also enabled as well. So crypto map, crypto ISCAM policy 1. Here are the options. There are always 5 of them. The group is the Diffie-Hellman group. Usually the higher the group, the better, but we're going to make it just fast. So first we're going to choose our authentication type. The options are pre-share, RSA, and RSA signature. RSA or random secure association encrypted, or random secure association signature I'm not going to create a digital signature, or I'm not going to create my own encryption method, so I'm just going to use pre-share, the easiest one to config. Basically, it's just a password or a public key. And then what type of encryption are we going to use? We can use 3DS, AES, DS in this router. Usually you don't use DES anymore. It's easily hackable and easily decryptable, especially by just a mere Wireshark. So we're going to make it harder for our hackers. We're going to use AES. Afterwards, we're going to choose our hash method. And we're going to cover up our passwords or plain text. We're not going to use MD5. Why? Because that's the over-the-counter protection, which means that it's only useful when you're protecting your password when it's on the monitor. For example, if someone tries to look at the monitor while you're typing the password, they will only see asterisk. As such, they won't be able to know your password. However, in the layer 2, layer 3, layer 4, layer 5 models, they can actually see it with a simple packet capture application, or like what I'm using, a Wireshark. So we're not going to do that. Instead, we're going to use a SHA-256. Could use 512, but that will take long for us. So, actually not that long, but yeah. Highest one right now is SHA-512. I suggest if you're going to configure IPSEC, use it. Next up, we're going to the Diffie-Hellman group. The higher the group, the better. But basically, if the certain configurations are not found in that group, it will start from the highest protocol, which is NRX24, to the lowest. But since I'm going to make it fast, I'm just going to use group 5, I guess. Yeah, it's on 1500 bits. So after that, I'm going to choose the lifetime. The default is 1 day. I'm just still going to do that 1 day. Why not? Oh, but you can also use how do you say this? Kilobytes, if you want. But it's not showing how time, whatever. You can also use volume. If I type volume, will it appear? Yeah, no, it's not applicable here in GNS3. But usually you have a volume, which means it will, instead of tracking time, it will track how many bytes of data have you sent before it closes down. So 86400, I believe, is 1 day, 24 hours. Exit. Now we've done the first part of our IPSEC, for our IKE phase 1. We're now going to apply a pre-share, which is fast. Don't ever use this as your pre-shared key. I'm just going to use it because it's easier. And you're going to share this public address to a interface, which in our case 2.2.2, which is the public interface of our R2. I haven't actually configured NAT yet, so if something goes wrong, it's probably the NAT. But since this is just a single router that I've used to access a cloud, yeah, no. So this should work. Now then, I'm going to create an access list, IP access list extended, VPN, and I'm going to permit IP 10.10.10.0 to 0.0.255, 20.20.20.0. So basically what this access list does is that whenever hosts or data coming from this network 10.0.0 is sent to R1 towards this network 20.0.0.0, it will then apply the IKE phase 1 to it. So it means that it will create a tunnel towards the interface into the 2.0 or our peer interface. Which means that IKE phase, which means like in GRE, we first created our tunnel, and then that's basically it. That's our GRE tunnel. In IKE phase 1, IKE phase 1 does it for us. It basically tells, hey R2, Why don't we create a secure tunnel for ourselves? Yeah, let's R2 then replies. Yeah, let's do that. How about we use these configurations instead? That's what phase 1 does. It creates a tunnel based from R1 and R2's negotiation. Now, since we've done that, we can go now to IPSEC, IKE phase 2. Basically, IKE phase 1 is ISACAM policies and IKE phase 2 is IPSEC. So, crypto, IPSEC. You can see now what we can choose. We can write a transform set, TS, or the word makes up, see, TS, name of the transfer set, and now we can choose between which authentication and encryption method are we going to use. As you can see here, we are going to use ESP or ESP. These are the methods. So I want to use, let's say, for our encryption method, we're going to protect it. We're going to use 3DS, and we're going to hash it. So we're going to cipher our. Oh no, not cipher. We're going to use an authentication method using. I don't want to use HMAC MD5. Let's use, how about 25 SHA once again, 256. Remember, usually, although it's shown here, E has encryption in it. So this is encryption. A here is usually authentication, like we've done here. See, we have a hash method and your encryption method. So that's how we hide and protect our payloads or data from the dangers of the internet, being stolen and such. And after that, actually, you can also choose which mode. So you can choose either tunnel transport. Tunnel is a datagram encapsulation, and payload is transport is a payload encapsulation. Basically, when it's a payload, you will encapsulate the payload, or you're going to encapsulate the payload only, and tunnel is for the header, I think, or the whole transportation or sending of the datagram. Basically, yeah. This is everything, then this is only a part of it. But since I don't really care about that for now, just configuring the VPN and IPSEC, I'm just going to leave it at that. Now, let's move on to the next part, which is the crypto map creation. Crypto map creation. Basically, this method is tying IKE phase 1 and IKE phase 2 together. Remember, you can use IPSEC in GRE as well. You can use IPSEC to protect your GRE tunnel as well. So, this is a required method. As you can see here, you can use IPSEC ISACAM or IPSEC manual. IPSEC and ISACAM is basically what we're doing right now. IPSEC manual is used for, I think, GREs. I haven't actually configured it like that. So I'm going to ISACAM. This new crypto map will remain disabled until a peer and a valid access list has been configured. Remember that. So we won't, ISACAM and ISACAM won't be up, as well as our protection method won't be created unless we have done the other router. So let's start configuring it. So our peer here is 2.2.2, or the source or the destination interface. Now, damn non-bad. 2.2. That's our set peer. Then set transform, what we made earlier. This is our phase 2. Remember. Transform set TS, and remember our match address or from our VPN traffic here. VPN match. So let's study this first. First off, I've set that peer 2.2.2, which is same here. This is our IKE phase 1. So we're creating the like I said, source and destination. In our case, we don't need to tell what's the source, it's us. So we're basically creating the tunnel here, the one side of the tunnel here. We're creating the IPSEC here, and we're matching the map address, or what are we going to protect or which network's data are we going to protect here. Must add VPN. So basically, every time and data come from this network comes here, it will then encapsulate it and send it through this tunnel. That's what basically. Now we're going to apply this crypto map into an interface, preferably the outside interface. Crypto map and CMap. That's the right name, and bingo. So it says our ISCAP is on. Show crypto map session. Yep, our session 2 is down. That's basically right. Do we have a peer? No. Shows crypto. What policy are we using? And do we have a peer? Nope, we have no peer because R2 is still not configured. Let's do the same here, but instead I'm just going to copy this one. This takes a long one. Ideally, if you're going to configure this, you have another partner from the other company. This is basically a company thing. You're securing your connection to another company, to another department of your company through the internet. Basically, it's like you're going to send what's the configuration that you're going to use, since if both of the routers aren't the same, it won't work. And because of that, you are going to type it into a notepad or another secure text editor or something, a text file, or maybe another configuration file. Who knows how secure you can be. So I'm just going to copy this, and I'm going to paste it here, and voila, I've created our ISACAM policy. But I have forgotten to type that lifetime because, like I said, it's already default. For our sake, just gonna type it. Exit. Next, we're going to create the. I'm going to create the our password, and the address is now not. Is our peer. This is one. This guy going to create the access list, permit IP or any data from 2.20.20.0 0.255 to 10.10 to network 0 plus 24. There we go. Exit. Now we're going to create our IPSEC policy again. Let's just copy it from here. There it is. See, we're using the mode tunnel. I'm gonna copy it here. And it's going to exit it. Next, again, we're going to create the crypto map. In this case, we are not going to copy it because our addresses are not the same. It's better to just map sec. Then sec ISACAM set peer to 1.1.2 or a destination. Again, be careful. Good thing I haven't disabled the warnings. TS address of VPN. Exit. And now we're going to apply it to a gigabit, our outside interface, which is 2.2.2 crypto map. Exit. And then, as you can see, ISACAM is on. I'm going to show you. Show crypto ISACAM here. So here yet. So we are down here. Now they're both down, but they are ready. So I'm going to show you our peer. Here. Now what? Oh yeah. Show you what happens. So this is our ping. Oh, damn it. It's too small. It's not much. Oh, well. So, look, we haven't actually enabled yet. Now, to enable this, we must be able to communicate from our router at least one time to our other router. So, they must be able to ping each other. So, we're going to do just that. Ping 10.10. Ping 20.20.1. There we go. 20.2. I'm going to ping this. That 20.20. So ping goes so that our VPN goes up. Here, this is ICMP timeout. Let's show it here. There we have it. I'm going to show it to you. So this is what we pinged from our 1.1.1.2. Because of that, ping, nothing changed, nothing, and look what we have here. Yup, we have our ICE account is finally up. So look at the interfaces, Ethernet, Ethernet type, IP. It sent a UDP protocol, which has an ICE account. This is our policy. This is our configuration here. And then, yup, it's from 2.2.2. It sent it back to 1.1.1 or R1. So this is our configuration. This is our. Right now, they are talking to each other. See, this encrypted, then scripted, and finally quick mode. So right now they've said, oh yeah, this is the configuration. Oh, we're going to use this one. Oh yes, I agree. We're going to use this one again. Okay, I'm going to send another packet to double check. Oh yes, everything is fine. This is what we're going to do. We don't need to do this process again and again. So they've sent quick mode. Yep, same. Everything's same. Nothing's changed. And look at this. We have our ESP. Remember what we've done? We use an ESP for authentication, ESP for encryption. Basically, this is it. This is all of it. So whenever you try sending again from PC1, send a ping towards the router. See, I've sent a ping, and then I received some encapsulated data. Again, I'm going to use the ping again. So instead of ICMP, I'm seeing this one. And what is this? It's IP and ESP. I don't know what is inside of this. It's just an ESP. I don't know if it's a ping, if it's sent a message, if it's FTP. Nope, nothing, nada. So basically, we've succeeded in our VPN creation. So, yep, I'm going to show it right now here using Auto. So, yep, as you can see, it is up. Now, no thing interesting there. ICE account here. We have a pair of 2.2.2 local 1.1.1. You can see the port, which means you can actually block this port if you want. But as you can see, using Wireshark, ICE account uses UDP. So if you want to block that port using SSDs, you might want to block it using UDP, not TCP. Prefer if you use IP. Crypto. Second, about sockets. We have no sockets to listen to, but math. So basically, that's about it. So this is our crypto map, and you're using a transformation ESP. Remember, ESP SHA-256H map. Now there are ways to, of course, decrypt this, but you must be using a packet capture and other algorithms that you may be able to find on the internet, or you may be able to buy, or you may be even able to create yourself. I suggest you don't create yourself, you just copy and paste from the internet. It's extremely hard. Don't reinvent the wheel unless your job is inventing other forms of transportation. But essentially, that's how you create a VPN traffic or VPN tunnel using IKE Phase 1 and IKE Phase 2. Next time, I might be creating a video about other channels. So look out for those switches and rapid switch mode again. And of course, I may be using IPSEC to protect my GRD tunnel. So, thank you, like and subscribe, and happy review, happy training, and good luck for your CCNA, or if you're reviewing your basic stuff. And it's CCNP, this is it. Thank you for watching, like and subscribe, and also hit that bell, and stay tuned for me creating a proper video tutorial within Micro Academy. Bye!